Hi, welcome. So today in this video, we'll be covering another theorem of circles, right? So let's begin that and I'll just share this with you. All right, so this is how we have got yeah, okay. So this is how we've got the theorem which we need to prove. And it says that if there is a circle and which is shown in this figure, and if there is a circle and there are two chords which are which you know uh, which of them are both of them are making equal angles with the diameter passing through their point of intersection, and we need to prove that both the chords are equal, right? So let's look at what we have in this figure. Here we have this as diameter PQ. Now that's the diameter we have, and O being the center point. O being the center point of the circle. Now here the two chords which are drawn are A and B, and the another one is C and D, right? Now what we need to prove is that we need to prove that AB is equal to CD, and it's given that these two angles, they both are equal to each other. All right. So now what we'll do is we'll consider these two triangles separately. Like we have triangle LEO, and then we also have triangle MEO. Okay. Now here in these two triangles, if we consider and we try and find out the value of this angle and then also this angle. So let's find out the value of first this, and that is angle LOE, right? Now here LOE, that's equal to, if we put the property of the sum of all the three angles of a triangle, then we can easily say that angle LOE is equal to 180 degree minus angle LEO and minus 90 degree, because this angle is also going to be the 90 degree. So we have taken that as 90 degree here. Now what we get here as an answer is 90 degree minus angle LEO. So we have got the value of this particular angle. Now let us work upon this angle. So that is angle MOE, right? And let's examine the triangle MEO for this, and that will be, this angle will be 180 degree minus angle MEO minus 90 degree, and that makes it 90 degree minus angle MEO, right? And we already know that what we know is that angles these two angles are already given equal. That's given in the question, right? That the diameter is passing through the is if the two intersection chords of a circle make equal angles. That means it's already given that these two angles are equal to each other. So what we can then say is that even this angle is equal to this, right? Because this is both equal to each other. So now if we consider triangle LEO, and let's Take triangle MEO. So let's look at both of these triangles, and we'll figure out that OE is equal to OE. That's being the common side. Okay, and we already know that in the question it is given that angle LEO is equal to angle MEO. That's given, right? Similarly, angle LOE is equal to angle MOE. This we just proved here, right? So if we say that, then now we can easily say that um, these two triangles which we were considering, both of them are basically congruent to each other. And if they are congruent to each other, then we can easily say that, you know, uh, OL is equal to OM, which basically means OM. Here is the O and this is L. Now this OL is equal to this OM because these two triangles are congruent to each other. And when we know that, there are two chords which are equidistant from the center, right? Then that means these two chords are equal to each other. So we can say that in this case, these two chords are equal to each other, right? Now, this is how we have done. Let's move ahead to one more theorem. And so that's here. Like, you know, it says that if there is an arc of a circle, then let's complete the circle. So, see, so far what we have learned is that it is to complete any circle, what we need is the center of the circle so that we can draw the complete circle. And without having any center, it is very difficult to complete the circle. Now here we'll see how we do it. So suppose this is the arc which is given, and we need to complete this particular circle. Let me just draw it a little properly. Okay. So suppose this is the circle which we have, and this is the arc which we have, and we need to complete this particular circle. So what we'll do is we'll first mark 3 points on this circle, on this arc. I'm so sorry. I'm again repeating this. Uh, on this arc, we mark these 3 points. Now, what we do is let's connect these points, and when we connect these points, they look like a chord actually. Both of them, they look like chords. So if we name them like A, B, and C, then we can say that both A, B, and BC are the chords if the circle is there. Now, what we'll do is we'll do a perpendicular bisection. We'll draw a perpendicular bisector of chord AB. So it'll somewhere be like this. Okay. And similarly, we'll draw the perpendicular bisector for chord BC also. Now that will be, something like this. Now this is the intersection point. So this we have as 90 degree. We also have this as 90 degree. Now we already know that, if there are two chords, and if there is any perpendicular bisector which is drawn on these chords, then it will definitely go through from the center of the circle. So, and the other chord is also going through from this particular point. So this is the only one point where both of these perpendicular bisectors are intersecting each other, and hence this point is the center of the circle. And once we know the center of the circle, we can then, considering this as the center of the circle, we can simply then, complete the circle. Okay. So this is how we do it. If we have any arc, then this is how we can complete the circle. So I hope you guys enjoyed, these two theorems, and I'll be coming up soon, next tomorrow, with the more theorems of circles. In case you have any doubts or something, you can obviously post your doubts in the comments box, and I'll be coming up with the solutions of those as well. Thank you so much. Have a nice day. Bye bye.